Wait for 2-3 minutes. Okay. Just now 12:01. So it is better to start after 2-3 minutes. এটা ই করুন। Dr. Giri, start now.
Yes, yes. Okay. Good noon to all. Today I will cover last topics, and last day I just completed the 2D plotting. Not finished the 3D plotting. So let's start the plotting. Hello?
Yes, sir.
Yeah, okay. So last day I just took the 2D plotting in the function y equal to fx is known on the table of values of this function. X and y is known. Then we plot this graph. How to change the line color, line style, and marker. Already I told you yesterday. Now from today, I told you that if the graph is of the form polar form, this is r theta is r theta form. Then how to plot the graph? One thing I will say you The how to format the figure window. How to format the figure window means how to mention the axis labels, titles, legend read on these things. Third, I will cover the 3D plotting. It means 3D 3D plot. 3D plot. 3D plot. Uh, 3D. There are four four type graphs. One is 3D line graphs. On 3D line graph, surface graph, surface mesh graph, and contour graph. Contour, contour graph. Okay. So let's start with software. Software. I will show you. So I want to plot the graph of sin x and cos x in the same window. So I write the program for that. So first we take a uh, uh, vectors for variable x from 0 to pi by 2 pi 0 to 0. I take a regular array with spacing 0.01 to 2 pi. Then y1 equal to sine of x. Then y2 equal to,
Sir,
okay,
Sir, cannot see your screen.
sir, screen is not visible.
okay. Okay. Now see,
Yes, sir.
Yes, sir.
okay, y2 equal to cos of x. Then plot a comma y1 with a line specifier. Suppose this is color red and line a line solid line. Then hold on plot x comma y2 line specifiers. Suppose blue color. Dash dot line. Then hold up. These things already I have discussed yesterday, so I think so. There's no question. So I save this script in the name of F1. Okay, I run this script. There's a two graph. One is the sine curve, one is the cos curve. But from this figure, uh, it is not seen that which graph is the for sin x, which one is the for cos x. and what is the x-axis, what is the y-axis on uh, these things. So for proper formatting, we have to add the other things, that is x level. X level. Yesterday also I got a question from your side, how to give the name of the uh, special symbols like theta, alpha, beta, like that. So today I cover this. X level, x level equal to within string. This is 0, 0, less equal to theta, less equal to less equal to 2 pi. Just like what we write in the latex, this command also is applicable in the MATLAB also. Then y level to, suppose there is no y level, because two function is there. So series graph for x-axis, giving the title, it is 0 less than equal to theta less than equal to 2 pi. Then we want to mention the which graph is for blue color graph, which one is which the graph, blue color graph is for hot function and red color graph for hot function. So this can easily understand by putting the command legend. Legend, there is a function legend in MATLAB, that legend. First one is the sin x. Sin x. Second one is the cos. Second graph for the cos x. So see, there is a in the top right corner, there is the small portion of each graph, red color graph. This is for sin x, and the blue color graph, the cos x, already it is shown. So from legend, we can easily understand which graph for what function. Then we can easily mention the title of the title. For title, there is a function, a title, 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 y equal to sin x and y equal to cos x, graph of see, after I run this script, the title appear at the top of the figure. See, the top of the figure. So then there is a command read on. There is a command read on. There is a command read on. Read on. Okay. This is so the grid. in the figure. See, same figure. There is a grid with the small rectangle. The plane is divided into small rectangles. From this, it is easily find out the uh, x and y values of the graph. Also, we can uh, mention the limit for the axis. So, how we do? Suppose x limit I want to I want only from pi to 2 pi. Pi to pi. X limit the, range of the x vector is 0 to 2 pi, by I want only 0 to pi. So I put this, the lower value and upper value. Lower value is 0, upper value is pi. Upper value is pi. Okay.
Sir,
Uh,
sir, someone asked to join in the class.
okay. Hello, sir. Hello. Sir, someone want to join, but can. Okay, sir will take care of this. See, when this x limit, axis limit, theta value 0 to 2 pi, but I not want all those values. I just particularly I want from pi by 2 to pi, pi by 2 to pi. Then just put the x limit equal to this. Then the graph just pi to just what value is mentioned, just pi by 2 to pi. This is the portion of the graph from pi by 2 to pi. So this way we can change also y limit. If I mention the y limit 0 to 1, only the positive values, not negative values. So these can also get from this figure. See, the only positive value sine graph. This is 0 to 0. In 0, its value is 0. Then pi by 2 it is 1. Then pi it is 0. Then after pi to 2 pi it is negative value, so no branch is here. So in this way we can format your figures. Okay. So see the presentation.
Sir, I just want to know one thing.
Just okay. Alex?
Sir, please plot the graph, please, again.
Okay. Okay. This is the graph.
This is the graph, and it is 0 to 2 pi. So here I can see to we want to display at the 7, matlab,
No,
0 to pi.
7. Okay.
I want to display here in term of pi, in x range.
Oh yeah, you want to these values from the in the x-axis or y-axis at a linearly scaled, this value automatically generated. If we want to change the form, uh, I think we have to edit the edit figure window. There's a edit option. From there, we have to manage. We have to manage, but in using programming, we cannot do the from 0, then pi by 2, pi 3 pi by 2, like that. Are you getting my point?
Yes, sir. Yes.
Okay. Uh, from through the programming, uh, uh, I did not see the how to change the it, but from the figure window, there is a option edit figure, edit axis
No,
properties,
from
edit
edit, it is. I think it is possible. I
from
this
these
is
properties you
from
can change.
direct command. I want
Uh,
to use a direct command. It is there. Okay, sir.
yeah. Next. Next, okay, I took the x level function x level, the argument, the string, whatever you want to mention the level of the x-axis. It's a same y level for the argument is also string. That means we can write this message within the single quote. So similar, I also told you the how the title command is. So title is a function title. The argument is the string. So this after executing this statement, the title appear at the top of the figure window, the top of the figure. Next, okay, I not. uh, demonstrate these commands, text and gtext. Okay, I come back. I will come back. But text and gtext. This is for the text message to your graph. I also told you the legend command basically used when they in one window there is a multiple graph. So which graph for what function we do not we do not easily understand by looking the figure. For that situation, you should apply the legend command to easily understand uh, the situation. That means multiple graphs, which graph for what function. You can also change the position of the legend. There is a there is position. uh, there is an argument post. The post value is different for different value. There is we can place the legend in different position. So default position is the right the upper right corner. Okay, axis already I told you the axis, x limit, y limit, and axis. Same way, axis for both x limit and y limit. Okay. For individual, we have to write. You have to write the x limit and y limit. Okay. Agreed one already I told you. Okay. Only one things to two function I have to demonstrate. One is the text gtext for text message. Other is the axis. Okay. Okay. See. Uh, see, instead of the x limit, if you put the axis command, within the axis command there is a array with the uh, with x limit, suppose 0 to 2 pi, then y limit, suppose 0 -1 to 0. Okay. From this one statement, we mentioned the x limit and y limit both. So see this. If you want the individual command, then you have to write except axis command. You have to write the x lim command and y lim command for individual limits. Okay. Now I want to tell you the how uh, function. Text function basically there is uh, first is the coordinate, which position you want to place the text message. Suppose here is the coordinate. I suppose x 10, comma y 10. There I want to place the values of, suppose, x10 and y 110, y110, y110. This is the sign suppose sin x. I want to put the message of sin x at the point x10 y10. X10 y10 means xy points on the graph. So see the figure. This figure, the x10 y10 point, there is a sin x. If you want this one in this point, suppose this is at pi by 2. Then what we have to write, x is pi by 2, this is pi by 2. Then y value is the, what is the y1 value? Y1 values at that point sin pi by 2 1. So see at the top pi by 2 at that time y value is 1. Then there is a message sin x. So gtext for gtext function, they both are same for message, give the message in the figure, but gtext not require the coordinates, points is not required, only the text you have to put as an argument. In gtext there is no coordinates, only the text message you have to put as an arguments. Then when if you run this program, then see there is a two perpendicular lines per section. When I change the mouse button, that is moved. So if you click this any point, there is the text message is, the message is message is stick there. So this way gtext is works. So these are the basically graph formatting commands. So any question about the formatting of the graph?
No, sir.
Okay. So I come to next polar graph. For the polar graph, okay, same way, but for polar graph, suppose t equal to 0, colon 0.1 colon pi by 2. I want the polar graph of a spider that spider there is the mathematical expression of a mathematical expression of a spider mathematical equation in polar form. Let's check it.
होता है
Suppose a mathematical form of a spider. Okay, this is R a t square minus L. R a t square minus L. Okay, this 0 to 10 pi. Where a is the value is the 0.01, L is the 0.02, and T 0. Okay. Suppose it is 0 to 10 pi, T value, then R equal to 0.01 into T square. T square means this is T is a vector, so you have to write T dot caret 2 minus L 0.02. Then I'm going to write the polar 50, R. Okay. 6, 8, 3. When this run, this speed run, see the figure of the excuse me. Hello. Okay, this is the polar graph of a spider. T equal to and not R equal to a theta square minus L. So in this way we can draw the polar graph also. Now I come to the point. Okay, another things also. I just tell you in the same window there is a multiple graph. There is a same figure window. There is multiple graphs, but it can also possible to divide the window window into the cells. For each cell, we can put the your graph. So suppose I want to put here is a sin x graph, sin x graph. Suppose here I want to put sin x. Here is sin 2x, sin 2x. In this window, I want to sin 3x. Suppose sin 3x, sin 4x, sin 4x. Or there is the sin list. So this is how to do this in the in MATLAB. It is there is a command subplot. Subplot that divide the window into window into cells, and we put each cell as a graph. So suppose sin x, I do it. Suppose sin x, then y2 equal to sin 2x, sin 2x, then y3, 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 y3 sin 3x, sin 3x, and y4, y4 equal to sin 4x, sin 4x. I want to place these four graphs in the four cell, one each. So how to do this? First, subplot is a command, subplot. So I want to divide the window into two rows and two columns. So put that two rows, two columns, and in the first position, first cell, I mention here. Okay, I want this x. Then similar way, I subplot of 2 by 2 at 2 position, I want of y2. Then the position, then second position, I want this. The third position, third cell, I want x y3, y3. And the fourth position, fourth position, the fourth position, the fourth position, I want this. Okay. What I write here, the window is divided into two rows and two columns, and the first position is this, second position, this is first position, this is second position, this is third, this is fourth. Okay. So I mentioned these things in the command, that is a subplot, subplot. So first argument is number of rows, second argument is the number of columns, then the position key of the figure. So when I save this and done, see this, the first cell, the figure window, sub window is that for sin x, this is sub window for sin 2x, this is for sin 3x, this is for sin 4x. So for here what we see that we can divide the figure window into several windows. So there are too many options in the there are too many way we can change your ideas. I demonstrate. You can change what do we see that in the figure here is the x-axis, y-axis is a linear scaling. You can change also, it is the logarithm scaling, that is also function. Instead of plot command, you have to put that semi log x. Semi log x means the x-axis is the logarithm axis and y-axis is the linear scale. Similarly, semi log y means y-axis scaling is the logarithm and the x-axis is the linear. When both the axes are the uh, both axis scaling is the logarithm form, then you have to use log instead of the plot. Now I come to the 3D plotting. So see the 3D. Basically for 3D plotting, like 2D plotting, there is a function uh, f of two independent variable x comma y. Okay, means two independent variable, one dependent variable. Otherwise, we have two dependent variable, one independent variable like this. Suppose x equal to gt, y equal to ht. The t is the independent variable and xy the dependent variable. So this is both the number 1 and 2 both are 3D. Uh, there is three axes. Both have three axes. So how to plot this? So here I told you already. I have told there is the four options, either line graph or surface or mesh or contour. So line graph, it is easy. So line graph, so we require three vectors of equal size x, y, z. Three vectors are required. Three vectors of same size. Then there is a command plot plot 3 x y z, which is show you the line graph of line graph of your data or information. See, there is a function xt equal to e to the power minus 0.2t cos 2t, yt equal to y2 equal to e to the power minus 0.2t sin 2t. So this what is see the line graph. When I do this, I descript. See the script t equal to 0 to 10, x equal to x exp equal to x equal to exp 0.2 into t dot star cos 2t cos 2 star t. Then x y equal to sin 2t. Y equal to 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 exp of 0.2 to cos 2t cos 2 cos sin 2t. Then plot 3 x y t. there. Good, good, good. Say t comma x comma y. Okay, see this. This is the line graph. Line graph for uh, the function xt equal to, for the function xt equal to this and yt equal to this. This is line graph, 3D line graph. Okay, but for the other three function, which is surface and mesh and contour, we have to form the plane as a grid. A grid. Grid means like this. We have to divide the plane like grids. Like this. Okay. This is the grid on plane. So for each of the crossing point, we have to find out the function value of z. Suppose the function is the z equal to f of xy. F of xy. So each point, x, if there is a x value and y value, we have to find the z value. So here for these three functions, surface or mesh or contour, we record the x is a matrix, y is a matrix, and z is a matrix of same size that represent the grid. Basically, x represent the grid, a grid matrix, y also represent the grid matrix, then the z represent the values matrix, function values matrix. So suppose the x values are 1, 2, 3, and y values are suppose y values suppose 0, 1, 2, 3, 4. Then what is the x matrix? X matrix means x matrix 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2, 3. This is the x matrix of size. There is 1, 2, 3. This size is 5 by 5 by 5 by 5 by 3. Then y matrix is y matrix. See y matrix. Y matrix is 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. This is the y matrix. Then we calculate the z matrix, capital Z equal to f of x, comma y. F is a function of x, y. Then z also matrix of order 5 by 3. This is called the grid, matrix grid. So in 3D figure, we have to calculate this. See, there is a function zxy equal to x square square root of x square plus y square. X equal to 1, 2, 3, and y equal to 1, 2, 3, 4. Then x matrix is the this, and y matrix is the this, and z value is this. So, we have to form the argument as a matrix x, y, z. Then we apply the mesh, surface, and contour. See, this for this graph, suppose zxy equal to x into e to the power minus x square minus y square. The limit of the x is minus 2 to 2 and y is minus 3 to 3. So how it graph the surface and mesh or contour. See it in the software.
Excuse me, sir. Sir, how
Okay.
to make X and Y matrix?
Okay, there is a function, but manually how you can write this this idea I will just told you. But there is a function that this uh, this function or when I create the grid matrix. So see that I just I, I will cover this in this program. So first there is a x limit x equal to minus 2 to 2 and y limit is minus 3 to 3. So I have to, so small x equal to minus 2 colon 0.1 colon 2. This is a vector, x is a vector minus 2 to 2. Then y is a vector of minus 3 to regular vector 3 to 3. So we have to we require the grid matrix. So for this grid matrix, so there is a command. It's x comma y equal to mesh there is a command mesh grid. Just we give the argument is the x is a vector and y is a vector, then it creates a grid matrix. This function create the grid matrix. See the individual command when they execute in the command window. How this statement are this statement are how this statement are works. Just see this. Suppose this is the not one. This one. Then y equal to, suppose y equal to minus 3 to 3. Then mesh grid x comma y see this. Okay, x comma y. See this, the x is a matrix and y is a matrix. There is a function mesh grid which will create the vector to the grid. Just one person asking the question how to how we get the matrix. Just you get the answer.
Yes, sir.
Okay. Then after that, this function just create the grid matrix. Then we have apply the uh, this matrix in the function. Okay, function is our function is the x x into e to the power minus x square y square. Okay, okay, x x into exp into minus x square minus y square minus x square minus y square minus x square minus y square this. But see, this is the this operator I already told that uh, star exponent, these are the basically have matrix operator. For dot operator, when element wise operation, you have to put the dot into star. Then it is also dot dot. Okay. Then for each corner of the grid, we have to get the function values. Function each corner, each corner, each corner, each corner, each corner point of the grid, we have the function value z. Then z is a matrix. So so this way we get the z matrix. Then then there is a function sharp sharp x comma y comma z x y z. Okay, okay. Now we save it f5, save it f5, run it. Okay, see, this is the surface of the function x into e to the power minus x square minus y square. Okay, also this is the surface of this graph. For mesh, you have to write, instead of surface, you have to write the mesh of this. Okay, mesh. See the graph for mesh plot. So just look this figure. I just asking the difference. What are the difference between the mesh and surface? I will ask. Just look this figure. This is the mesh graph, and for surface, see the surface. This is the surface graph. So what is the difference between two? Anyone can give the answer? Hello? Anyone? What is the difference between two graph? Okay. See, here is the surface. Surface is all the grid is filled with the color in the surface graph. In the surface graph, the grid are filled with the color. But in the mesh graph, see mesh in mesh, it's mesh graph, see the surface, each grid is not filled with the color. That means mesh graph is basically wired. Grid are wired, and in the surface graph, grid are wired and filled with color. Then for the contour, so contour, see that there is a command contour. Okay. Contour, see this is the contour of this function. Okay. So just I covered two things. So line. Okay, okay. Line graph, 3D line graph, surface graph, mesh graph, contour graph. Okay, there is also the option. There is also option surface with contour. There is a function surface with contour. CSURFC. This is function. There is the surface with contour. This is the surface with contour. Similarly, mesh with contour, there is a function mesh C. So this is the just this graph. Uh, for this 3D graphs, you also mentioned the X level, Y level, Z level, and title, and the text like the similar way of the 2D graphs. So the similar way 2D graph, the X level, title, X level, Y level, Z level, like this. Okay. Okay, this is this discussion. I covered the my graph plotting class. So, if any question in the plotting, please ask. Then I go to the ordinary differential ODE. So, if any you have any question, please ask. If you have any question, happy to answer you.
Sir, sir,
Uh,
please open the code which are with contour, graph with
okay,
contour.
okay, contour. This is the surface with contour. Uh, any other question?
স্যার আপনি মাইক্রোফোনটা কি
Any
অন
other
করেন?
question?
মাইক্রোফোনটা
There
কি
is
অন
no
করেন?
question. Then I will start the ODE.
মাইক্রোফোনটা অফ করেছিলেন
ODE. Chalo,
এই যে মাইক্রোফোনটা
I going late.
আমি অন করলাম।
ODE, ordinary differential equation. We know the definition ODE. Basically, uh, 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 most of the engineering problem or physical science problem, we know the differential equation, either ordinary differential equation or partial differential equation. In the ordinary differential equation, there is one independent variable and the dependent variable and its derivatives. It is a function of, suppose it is a function of independent variable t, dependent variable y, and its derivatives is a y dash, y double dash, like that way, yn equal to 0. It is a function of this. So we also know that if it is the n or n initial or boundary condition, then we get the exact solution. But analytically, we cannot solve any ODE. Right? Any ODE for any ODE, we cannot solve the using an analytic method. We have to apply the numerical methods. So there is we can also any order ODE we can transform to the system of first order ODE. So first order ODE, we know that y dash equal to f of dy. It is the first order ODE. So any order ODE we can convert to a system of first order ODE.
মাইক্রোফোনটা অন করে
Like
রেখে দিয়েছি।
suppose
একটা
one
মাইক্রোফোনটা অন করে
ODE
রেখে দিয়েছি।
y double dash plus suppose y double dash equal to 5y dash plus 7y equal to suppose 0. Then this ODE we can this is the second order ODE, second order ODE. So this ODE is converted into the simultaneous third order ODE. How? Say I put y1 equal to suppose y and y2 equal to y dash.
Sir,
With this,
এই থাকলো দুইটা
we
স্টপ
get that y1 dash equal to y2 and y2 dash equal to y double dash. That means y double dash equal to minus 5 y2 minus 5y2 minus 7 y1 minus 7y. That how we can write this in the vector form. Y capital Y equal to suppose capital F of t comma y. Here F equal to F of this equal to the vector form to the y2 and that is the minus 5y2 minus 5y2 minus 5y2 minus 7y1 y equal to y is a vector is the y1. So in this way we can convert also multi order ODE into the simultaneous first order ODE. So my first I tell you how to solve the first order initial value problem. First order. That means you have y dash equal to f of t comma y with y t0 equal to suppose y0. At the initial point there is a value. This is the first order ODE. So for this basically here numerical MATLAB is used for these types of ODE where the analytical solution does not exist or analytic solution cannot easily find out. For that we have to we apply the numerical methods. So basically our target is that for the for t values, suppose time span in the range, in the domain, suppose 0 to 10, in range in this interval 0 to 10 interval, we have to calculate the y value, suppose y0, y1, a sequence of value y2, y3 dot like this, yk dash dash. So this sequence of value we have to find out that not exact, that not match with the value. Suppose tn, y of tn is the approximate values of y. Analytically, if we get the value, then this is the ty. Analytically we get the result, then this is the ty. this function, and numerically we get this is the discrete value tn at the point tn, it is yn, and analytically the value is erased. But these two are not same approximate. The difference is the errors. So numerical methods, some error is there. So for this control, there are several MATLAB techniques, but frequently used techniques is ODE 45. ODE 45. ODE 45 basically RK methods. For the RK methods is used here. Need to find out the solution. So I come to the solution of any first order ODE. So this in this lecture I covered the definition. I already told how to define the M function, when a MATLAB function for ODE, solving the first order ODE. First order system of first order ODEs, higher order ODEs, all are boundary initial values, then how to solve the boundary values ODEs. So this will cover here. So I already told that this is the ODE, the mathematical form. This convert to the simultaneous ODEs, first order ODEs. The vector form. This is the vector form. Okay, one example is there. But this is the third order ODE. This convert to a system of ODEs. So how to define here? We have to solve the any ODE initial value ODE. We have to define two functions or two scripts. One is the for ODE, one is for execute the solver. So we have first have to define a function for ODE, then define the time span, initial condition, option, and within the script where is the solver ODE 45 is called. Then run the script file, analyze the result as a plot of the state and t. So for that, suppose I take here the example dy by dt equal to suppose this is the first order ODE dy by dt equal to 2y minus, suppose 2y minus 0.01 y square with the initial condition y0 equal to suppose y0 equal to 1, the initial condition 1. So first I have to, this is the first order ODE. I have to define a function for this ODE, then a script file. So yeah, I will do it. I do it in the script in MATLAB. Suppose first I have to define a function. So this is the function. So function. Suppose output variable is the dy equal to suppose function 2, the ODE1 and t comma y, then dy equal to 2 into y minus 0.01 into y 2 y square. Y square. This is the function I have defined for the ODE. Then ODE1. Then I have to write the script file for that. So for script file, we have to mention the time span, TS time span. Suppose this time span is the 0 to 0 to suppose 10, 0 to 10, 0 to 10. And initial value is y0, y0, y0 equal to 1. Then for the function, for the function, for the function, for the function solver, suppose ODE 45. This is the solver. I call the function t comma y equal to ODE 45. ODE 45. First argument is the first argument is the ODE function, that is ODE1. Then the time span TS, then initial values y0, then initial values y0. Okay. Then I plot of t comma y. Okay. So this is the this is the script for the ODE. Okay, see the graph. So solution graph of this first order ODE. This is the graph for horizontally t and vertically the y value. Vertically, if you want to see the values of y and t, see in the command window, the t values are, this is the t's value and corresponding y values. I want to the t and y values. Suppose display t comma y. See the this is the first 0, 1, it is given the initial point, then the for each of the t there is the y value. So our target in numerical methods to solving the differential equation, our MCs, I just told you that our MC is find out the sequence of values y0, y1, y2, y2. Then analyze the graph. So there is a vector. One vector is the t vector, time vector. One vector is the y vector. So putting the two vector in the plot command, we get the 2D graph. I just discuss that in the lecture of 2D plotting. So in this way, we can solve the first order initial value problem. Now I come to the simultaneous first order ODE. First order ODE with initial value. Suppose this is a function for the a predictor model. A predictor model. There is a two first order ODE with initial condition. One is the y1 equal to this. So y1 dash first y1 dash equal to y1 dash equal to y1 dash equal to y1 dash equal to 0.08 minus suppose 0.01 y1 y2 0.01 y2 whole into y1, and y2 dash equal to, suppose this is 0.02 minus, suppose 0.02 that's a 0.02 okay. This y2 dash equal to 0.001 y1 minus 0.02 into y2. This is our 2 first order ODE with initial condition y1 0 y1 0 equal to y1 0 equal to 100, y2 0 equal to 40, y1 100 and y2 0 equal to 40. So how to solve this? This is a simultaneous equation. For that, we write in the matrix form, vector form, capital Y dash equal to capital A t comma y. Capital Y dash means y1 y2, and f equal to just say 0.08, f equal to 0.08 minus 0.01 y2 into y1, and this is 0.0001 y1 minus 0.2 y2. So for that, we similar way we can write the function, ODE function. Suppose OD2 t comma y, OD2 t comma y, dy by dt. This is the array. There is a two values. First is the first value. This is the two values. There is two values. First value is the first value 0.08 minus 0.08 minus 0.01 0.08 minus 0.01 into y1 into whole into I think y2 sorry, this is the 0.01 y2 whole into y1. This is the y2 and this is the y1. The second one is the 0.0001 0.00. Second one is the 0.0001 into 1 into y1 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 minus 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 0.02 whole into y of 2 y of 2. Okay, this is the this is the function ODE function for this two first order ODEs. Then the next is we have to write the script for that script. Time span is suppose 0 to 100. The y value y0, this is two initial value. One is the 100 semicolon, then 40. The ODE 2 is 2 is y0, then plot t of y1 okay, then this is and the plot t comma, there is a y has two components y1 y2, so y of 1 comma 1 is one plot function, and other plot function is the plot 2 to display t comma y. Okay, let's see this the result. It is a small time span. See this small time span. See, there is two curve, but two values is there. Plot t comma y another also, hold on. See, there is a two graph. One is the blue red color, one is the uh, orange color. So these two graphs must come in the same way. Also, okay. Hold on, hold, hold on. This is the mistake. So that's why hold. Okay. See, this is the two solution. One is the y1, and that is y2. So that this time already time is over. So if you have question, there is other also topics. There is uh, uh, second higher order OD, how to solve. This is the higher order OD. Third order OD. For this is there we can make it the system of first order OD, then solve it. Then for the boundary values problem, that this is this for boundary values problem, this is some other techniques to there is a function VP 4C. First, we have to convert the for all the all order first higher order OD to the system of simultaneous system of first order OD. Then also convert the boundary conditions into the in this form. Then you have apply the then you apply. This is the function definition, boundary value problem. Then the this is the residue, means the initial condition. This is for the there is a function the boundary value problem for C. This will give the result of your boundary value problem. So already time is over, so I do not want to extend my class. So if you have any queries or question, then I just answer to your question. Hello? Anyone have a question?
Yes, sir. So when we draw a graph, sometimes we define that SYMS x comma y before the plotting. So what is this? Why we define SYMS x?
Before the plotting, define.
So this is when we start the coding before the start the coding, the first line is we define in the book that you recommend yesterday SYMS x comma y if you are defining the graph between x and y variable. Sometimes they use that SYM and sometimes they use that SYMS.
What I'm not getting what is the syntax? F
Yes, sir. Yes.
F. I'm not getting your the voice. So it's speak loudly.
Yes. Sir, as you recommend the book for yesterday,
Yes.
in the book the 2D graph, they are using first line SYMS x comma y. After that they start the coding for the graph.
So before that there is a percentage sign.
No,
If the
sir.
percentage
This
sign is
this
there, this is the for command, just not
Yes,
executive line. This is the command
yes, sir.
line. Okay. Then the for to clear the figure window, there is a command. I think this is for CLF. CLF is there. You are asking the CLF.
No, sir. Sir, I am asking. Suppose we have to plot a graph. For graph, they use they use that S Y M S, then
Oh,
X
this
comma
is the
Y and plot X comma
system variables. S S Y
M
S
S.
Y
Yes, sir.
M S.
Yes, sir.
S Y S
M S.
S Y M S.
Yes, sir.
This is for the word for the defined system variables. But I not giving any the idea of the system variables. System when you execute the expression in the analytically, you have to mention the system variables. Then the expression, what variable are used, this is the like the variable we know, the system also understand this. What we know,
Yes,
the
yes, sir.
variables, the system can understand this variable.
Sir, it is different from the user-defined variable.
Yes, yes. It is like we know the variable concept, continuous case. We know the variable, this is continuous for our domain, like this is computer also understand.
Okay, sir.
Okay. Any other question? Okay. If there is no question, then I just stop here. So thank you, giving time me. Thank you.
So next session will start at 2 o'clock sharp.